first question here, I equals to 0 to pi by 2 cos square x dx. Now one way to do this question is use the double angle formula. That's by indefinite integral way. Here we'll try to use the properties. So what I'll do, I'll replace, this is like 0 to a, replace x by pi by 2 minus x. So I equals to again 0 to pi by 2 cos squared pi by 2 minus x. Now what is this? This is nothing but the sine square. This is sine square x dx. You know this. Call this as 2. Call this as 1. Now what I'll do? I'll add 1 and 2. Adding 1 and 2. Adding 1 and 2. So what is left hand side? I plus I is 2i. 0 to pi by 2. Here cos square, here sine square. I'm adding, remember. So cos square plus sine square. This 1 here. This is just 1. What's the integral of 1? X. What are the limits here? 0 to pi by 2. So this is pi by 2 minus 0, which is pi by 2. But this is 2i. You want just I. So what is I? Pi by 4. So this is with the help of properties. Right. What is another way of doing the same question? With the help of indefinite integral. You can do like this. This is also correct, remember. I equals to 0 to pi by 2. Use double angle formula. One of the points to remember. 1 plus here cos 2x whole by 2. This I'm just showing you. 1 by 2 outside. Integral of 1 is x. Integral of cos 2x is sine 2x by 2. Limits are 0 to pi by 2. Apply the limits. Again you will get the pi by 4 only. Right. Normally in the exam you will not be given use the properties. But whichever way you like, you can do it. Here this is the exercise based on the properties only. So what we do, we try to use properties here. Which property I have used? Here that 0 to a fx dx. If you remember, I've used this property here. 0 to a fx dx, that's equals to integral 0 to a f of x is replaced by a minus x. I've used this. So here what I did, x is replaced by a minus x. So instead of x you write pi by 2 minus x. That's what I did here. Fine? Okay. Question number 2 here. Integral 0 to pi by 2. So 0 to a, remember, root sine x upon root sine x plus root cosine x. Now this question by indefinite integral procedure, it's not easy to solve, remember. So what we do, we use the property. Which property is 0 to a, then x is replaced by a minus x. So you can just write by a property. No need to write the property number. By a property, your x is replaced by x minus pi by 2. Pi by 2 minus x, pi by 2 minus x, a minus x. X is replaced by a minus x. So therefore, we'll get the same integral. I equals to again 0 to pi by 2. This is sine pi by 2 minus x. So this would be just cos x. What is this? Sine pi by 2 minus x. Plus here cosine pi by 2 minus x. X is replaced by a minus x. A means pi by 2 here. So pi by 2 minus x. Now here 0 to pi by 2. You know that this is root cosine x upon this is root sine x plus what is sine, so this become cos x, and this is again root sine x. Call this as 2. 1 that is given question. Now normally when we use the properties, you always notice that the denominators would be same. Here you see this denominator and this denominator are same. So in such questions you can add these two. So adding 1 and 2. You're adding 1 and 2. As we did in the previous question. This is very common procedure in this definite integral. So I plus I, that is 2i. You have the common limit 0 to pi by 2, 0 to pi by 2. What is function here? This much. So I'm writing here root sin x upon root sin x plus root cos x. Plus here you have this, that is root cos x upon root of cos x plus root of sin x. And then here the whole dx. What I did, we have just added these two integrals. Okay, now why we have added this, you must realize this become here, you see this is a common denominator. So you have root sin x plus root cos x. This is a common denominator. What's the numerator? Sin x plus root cos x. You can see that this becomes just 1 here. What's the integral of 1? Integral of 1 is x. And what are the limits here? 0 to pi by 2. This is 2i. 0 to pi by 2, remember. And if you just write upper limit minus lower limit, pi by 2 minus 0. And therefore, I would be, I means here given integral, remember, which is pi by 4. So the value of the integral is pi by 4. Question number 3 is also just copy of this. Here root means raised to 1 by 2. There you have raised to 3 by 2. So in the third question, if you add them, again you will get the 1 there. So if I just show you, question number 3 here, in the third question, call that as I. Question number 3. I equals to, you have 0 to pi by 2. This is sin x raised to 3 by 2 upon cosine x raised to 3 by 2 plus sin x raised to 3 by 2. Call this as 1. Now using a property, no need to write the property. Using a property, replace x by pi by 2 minus x, a minus x. So you will get I equals to some expression here. Sine would be replaced by here cos. This cos would be sine, and this sine would be cos here. Call this as 2. And then just add 1 and 2. Adding 1 and 2. If you add 1 and 2, you will see that the left hand side would be I plus I would be obviously 2i. But RHS would be 0 to pi by 2. Denominators are same. Here cos, here sine. So this is just 1. You can notice this. Now what's the integral of 1? That's x. Limits are from where to where? 0 to pi by 2. So upper limit minus lower limit. Pi by 2 minus 0. So 2i equals to pi by 2. So I is pi by 4. This is the required integral here. Question number 4. Same question. Start with I equals to 0 to pi by 2. Cosine raised to 5. Instead of 3 by 2, here you have 5, remember. Upon you have sine raised to 5x plus cosine raised to 5x dx. Call this as 1. Replace x by pi by 2 minus x. Then again you will get a I, which is 0 to pi by 2. Sine raised to 5 upon this is cosine plus this is sine. This is 2. And then adding 1 and 2 here. Adding 1 and 2. If you add 1 and 2, I plus I is 2i here. 0 to pi by 2. If you add this, this is just 1. This is pi by 2. So I is again here pi by 4. Same answer. You can just verify as we did earlier questions here. So in the fourth question, the final answer is pi by 4. question number 5 and 6 both are about modulus. Minus 5 to 5 modulus x plus 2. Sixth question, let me write here only. The question number 6 here. That's integral 2 to 8 modulus x minus 5 dx. Okay. Now in such modulus questions, what we do, this is very common practice. Find the x for which modulus becomes 0. For what value of x this becomes 0, that is minus 2. And at this place we'll split into the two integrals. So minus 5 to minus 2 plus minus 2 to 5. Here dx, here dx. Now what will be the function? Why we split at minus 2? Because for this value of x this becomes 0. Okay. Now we'll just check from minus 5 to minus 2 whether this is positive or negative. So you take any number from this and you can see that this will be negative, and when inner number is negative, modulus is replaced by minus sign. If this is negative, then the other one has to be positive, so here modulus is replaced by itself. Which concept I've used here? I've used this concept, remember. Modulus x equals to x if this is positive. If this is negative here, then the modulus is replaced by minus x. That is the minus sign in front of the inner expression. That concept I have used here. So what I'll do, first we find x for which this becomes 0. That is at minus 2 it becomes 0. Now we split this integral at minus 2. Minus 5 to minus 2, minus 2 to 5. Okay. Now what about the function? From minus 5 to minus 2, whether this is positive or negative, that we want to decide. So pick up any number from minus 5 to minus 2. For example, let's take minus 3. Put here minus 3 plus 2. This is negative. That means this expression is negative. So when you drop the modulus, you have minus sign in front of this. Now if this is minus sign, then this has to be plus. So no need to check for this. Still, if you want to check, take a number from minus 2 to 5. Suppose I have taken, say, 0. Put there 0 plus 2, 2 positive. So modulus is replaced by itself. This is the only important part. Now integrate as usual, remember, as we did. This is very simple linear function. X squared by 2. Integral of 2 is 2x. And limits are from where to where? Minus 5 to minus 2 plus, what's the integral of this? X squared by 2. And integral of 2 is 2x. And what are the limits here? Minus 2 to 5. X squared by 2, 2x, same, just limits are different. Now put upper limit minus lower limit. So first upper limit, here 4 by 2, this is just 2. Minus 2 square, 4 by 2 it is 2, and here minus 4, this is upper limit. Minus, now lower limit, this is 25 by 2, 25 by 2 minus 10, plus, now we are over here. First upper limit, so this is 25 by 2 plus 10 minus, now lower limit, so this is 4 by 2 which is 2, and this here minus 2, so this become how much? Minus 4. Simplify, so you will get your final value, remember. Okay. Now I'll come to this portion, remember. Same procedure. What we do? First we find x for which this becomes 0. So for what value of x this becomes 0? That is 5. So we split it at 5. So here integral 2 to 5 plus here 5 to 8. Upper limit is 8, remember. 2 to 5 and 5 to 8. This is one of the property you know. Now about inner function. You take any number from 2 to 5. Suppose I have taken 3. Put here 3 minus 5 minus 2. This is negative. Inner expression is negative. So when you drop the modulus, you have minus sign in front of this. So x minus 5 dx. If this is negative, then this is always positive. So x minus 5 dx. Always first integral is normally negative, second is positive. Here negative, here positive. Now, as I did previous, just integrate it. What's the integral of this? X square by 2 minus 5x. Minus sign is already there. Limits are 2 to 5. What about this? X square by 2 minus 5x. And limits are from where to where? 5 to 8. And now upper minus lower, continue further, so you can do it. One more question is there, question number 18, which is again about modulus. So let me just show you over here only. Question number 18. 18th number. Integral from 0 to 4 modulus of x minus 1 dx. Every modulus question has the same procedure. Find x for which this becomes 0. That is x equals to 1. So we split at 1. 0 to 1 plus 1 to 4. 0 to 1 and 1 to 4. Okay. Now here in the first integral always it is negative. So minus x minus 1. And second integral it is always positive, so x minus 1 dx. And now as usual, integrate it upper minus lower. I'll again explain why this is negative. You take any number from 0 to 1. Suppose 0.5, place here, inner number is negative. If inner number is negative, then the modulus is replaced by minus sign, so I have minus. If the first one is negative, the second one has to be positive, so here plus. Or you take any number from 1 to 4. Suppose I have taken 2. Put here 2 minus 1 positive. So it's replaced by itself. Now as usual, this is very simple linear function. Integrate it, write upper minus lower as I have shown in the previous two examples. So next question number, let's do 7th. I equals to integral 0 to 1 x into 1 minus x raised to n dx. So we use that property, replace x by a minus x. So by a property you can write replace x by a minus x. A is 1 here, so 1 minus x. So you can see that here, same integral 0 to 1, x is replaced by a minus x into here, this 1 as it is, this x is replaced by 1 minus x. What I did, I've used that property, replace x by a minus x. So wherever you have x, just put 1 minus x. 1 minus x, 1 as it is, x is 1 minus x. Now here integral 0 to 1, 1 minus x as it is. 1 will get cancelled, this is x raised to n. You can see that by this property, power is shifted from this expression to this, you see. Here it was x, here x raised to n. Now this bracket can be opened very easily. 0 to 1, 1 into x raised to n, that is x raised to n, minus here x raised to n plus 1, the whole dx. Integrate it. This is a simple polynomial function, n plus 1 upon n plus 1 minus, raise the power by 1, n plus 2 upon n plus 2. Limits are from where to where? 0 to 1 here. Now upper limit minus lower limit. So put x equals to 1 first. 1 upon n plus 1 minus 1 upon n plus 2. 1, 1 here. Minus, now lower limit. Here 0, here also 0. So therefore, if you do just cross multiplication, n plus 2 minus n plus 1, so it is just 1 upon n plus 1 into n plus 2, the value of the integral. Now in the exam, if it is not asked by the properties, the question is, can we do it by indefinite integral? The answer is yes. How do we do by indefinite integral? Can you think? Yes. Where is the problem? The problem is with this, remember. You cannot expand this. That's why you see power got interchange here by the property. So in indefinite integral, whenever you are facing with some expression, take that as a t. So put 1 minus x equals to t. Differentiate this, 0 minus dx equals to dt. So dx equals to dt. And now integral here, what is x? It is 1 minus t. And this is t raised to n. Here dx equals to minus dt. So I'll keep minus outside and here dt. And now it's, you see, now it's same question here. So you can continue now. So this is by indefinite integral, by taking substitution. Here I did with the help of a property, remember. Here I did as an indefinite integral. In the exam you can do either way if it is not written by the properties. Okay. Question number 8. Eighth question here. That is integral 0 to pi by 4 log of 1 plus 10x. Call this as I. Now this by indefinite technique, this becomes a little difficult. But if you use the property, replace x by a minus x, that is pi by 4 minus x, by a property. What we do? We replace x by a minus x. So therefore, the above integral 0 to pi by 4 log of here 1 plus, this is 10 pi by 4 minus x. What we did, whenever you have x replaced by a minus x, this is x that is placed by pi by 4 minus x. Now obviously we need to expand this. Here integral 0 to pi by 4 log of 1 as it is right now. What is this? 10x minus 10y, that is 1 minus 10x upon 1 plus 10x. 10 pi by 4 is 1 into 10x, the whole dx. 1 plus 10x, which is pi by 4, minus 10y, which is 10x, upon 1 plus 10 pi by 4, which is 1 into 10x. Simplify inside the bracket. 0 to pi by 4 log of, take LCM here, so 1 plus 10x plus 1 minus 10x upon 1 plus 10x. Just simplifying inside the bracket, remember. So here you have integral 0 to pi by 4. What is numerator? It is just 2. 2 upon 1 plus 10x. Okay. Now this is equals to, we use the property of the log function, 0 to pi by 4. This is log 2 minus log of 1 plus 10x. Log 2 minus log of 1 plus 10x. Split into two integrals. Log 2 being constant outside, 0 to pi by 4, 1 dx. What is this? 0 to pi by 4 log of 1 plus 10x. It's a given question. You can see here. So that is I. So minus I. Left hand side was again I, remember. In any definite integral, when you start with the question, call that as I. Now this I will go that side. So this is 2I. Log 2 being constant as it is. Integral of 1 is x. Upper limit minus lower limit, that is pi by 4 minus 0. Okay. And therefore, here the I would be finally pi by 4 by 2. So pi by 8 into log 2. This is the required integral in this case. Question number 9 here. The same procedure. Replace x by a minus x, that is 2 minus x. Right? Or if you want to do by indefinite integral, you know the method. Put inside the square root as a t square. You know, this is by indefinite. I'm just reminding you. Put inner expression equals to t square. One of the points to remember. Here, replace x by, replace x by 2 minus x and just continue. You can do it. Okay, I'll go to question number 10 here. 10th question. Let me call this as I. I equals to integral 0 to pi by 2. 2 log of sin x minus log of sin 2x. So obviously here the first step is use the properties of the log function. So here 0 to pi by 2, this 2 will go in power, so log of sin x the whole square minus this is log of sin 2x. Now again log a minus log b, that becomes division here. So this is log of sin square upon, what is this? Sin 2x, which I'll write 2 sin x cos x. So this is integral 0 to pi by 2 log of, what is this? This 1 by 2 as it is here. 1 sine will goes away and sine upon cos, that's 10x. So it is half 10x. Now again I'll use the property of the log function because I know something about log 10x. So this is log of 1 by 2 plus log of 10x. Which property? Multiplication becomes addition. Now this being constant, you can take it outside. You can write 1 by 2 means 2 raised to minus 1, integral 0 to pi by 2, 1 dx. Here I have taken this much outside. Plus integral 0 to pi by 2, log of 10x. Okay. So here this is just log 1 by 2 as it is. This is x here, and if you do upper limit minus lower limit, this is pi by 2. Plus we need to compute this separately, so I'll call this as I1, equation 1. Okay. We find value of I1, we place in equation number 1. This one as it is, log of 1 by 2, as you can see, integral of 1 is x, and then you do upper limit minus lower limit, so we'll get this much only, pi by 2 into this much. We call this as I1, we do it separately and we place in the equation number 1. So now I'm finding I1, 0 to pi by 2 log of 10x. So same procedure, what we do? Replace x by pi by 2 minus x. So this become cot, So integral 0 to pi by 2 This is log of cot x. It is tan pi by 2 minus x. So it is just cot x, we know. Okay. Now, how do I rewrite? Integral 0 to pi by 2. This is the log of tan x raised to minus 1. Cot means 1 upon tan. Minus 1 will come in the power because of log. So minus 1, 0 to pi by 2, log of tan x. This minus 1 will come in product. Now what is this? This is again I1, you can see. So therefore I1 equals to minus I1. So 2I1 equals to 0. And therefore I1 is 0. So the value of I1 is 0 here. So therefore, if we go to equation number 1 by 1, I means given integral, that is log of 1 by 2 into pi by 2 plus 0, and therefore this is the answer, log of 1 by 2 into pi by 2. Question number now 11. In 11th question you have integral from minus pi by 2 to pi by 2 sine square x dx. Now this being a square, here fx equals to sine square is even function. Because square is there, f of minus x will be same as fx. You can verify, replace x by minus x, it will be same because of the square. So according to that property, this becomes twice 0 to pi by 2 sine square x dx. And you know now how to integrate. In fact, you know two different ways. One, you can use double angle formula, or you can replace x by pi by 2 minus x. There are two ways. One is this. Put x by pi by 2 minus x, or another way is use sine square x equals to, you know here, 1 minus cosine 2x by 2. Either this or this, whichever way you want to do it, you can do it, and then just upper minus lower, remember. Next question. That's question number 12, same question. Replace there, 12th question, if you just look at. Replace here x by pi minus x by a property. And just continue, you can do it, I'm sure. Question number 13, there I equals to integral minus pi by 2 to pi by 2 sine raised to 7x dx. You have opposite limits. Now in that 11th question you had even power, remember. Here you have odd power. So function fx equals to sine raised to 7. Sine itself is an odd function, and you have an odd power, is an odd function. Is an odd function. So here x is replaced by minus x. So f of minus x become minus fx. You can just verify. And once it is an odd function, nothing you have to do. The value of the integral is 0 by the property. Remember, if it is even function, then integral will be double UC, and the limits from minus pi by 2 to it becomes from 0 to pi by 2 for even function. For odd function, the integral will be 0 directly, but just you have to see carefully whether it is an odd function or even function, remember. Next, question number 14, you will try yourselves. Think about it. I'll go to question number 15. Question number 15, there we have I equals to integral from 0 to pi by 2 sin x minus cos x upon 1 plus sin x into cos x. So the obvious way is here, by that property replace here x by a minus x. So by property replace x by pi by 2 minus x. So therefore I would be 0 to pi by 2, limits will be same. Cos sin pi by 2 minus x, it is cos x. Cos pi by 2 minus x, it would be sin x upon 1 plus, as it is, sin pi by 2 minus x, it would be cos x, and cos pi by 2 minus x, it is sin x dx. As we know, call this as 2, call this as 1. We add these two. When we do, usually when we have equal denominators, you see this denominator and this denominator are equal, so we add them as we did earlier. So adding 1 and 2 here, adding 1 and 2, so I plus I, that gives us 2i, integral 0 to pi by 2, both the denominators are same, so I'll write here 1 plus cos x into sin x. Limits are also same, 0 to pi by 2. Now we add these two numerators. This one is added with this. So what happens if you add these two? Cos will get cancelled. Sin will get cancelled. So this becomes just 0. And so the entire expression will be 0. What's the integral of any 0 constant? Say C. Limits are from where to where? 0 to pi by 2. If x is there, then you put pi by 2. X is not there, so C as it is. Minus, if x is there, then you put 0. But x is not there, so again C. C minus C. That gives us 0. So 2i is 0, and therefore I equals to 0.